finish the warm-up. Pause it now and complete the warm-up. Number 1, Evelyn's able to run a half of a mile in 1/8 of an hour. If she has a goal to run 10 miles, how many hours will it take her to complete the goal? Here's the key. The ticket is going to give you the units in the same sentence. We know we're comparing miles and hours. And we know that over the course of 1/2 of a mile, it took her 1/8 of an hour. We also know that her goal is to run 10 miles. So 10 is where we're keeping track of the miles. We don't know how long it will take her to do that. From here, I'm not going to show it to you because you know how to do this. You cross multiply, so you do 10 times 1/8. You do 1/2 times x, and then you would solve the one-step equation. Number 2, these should be pretty easy by now, considering it's Friday. At a zoo, there are a total of 80 animals, and 25% of the animals are predators. Of the predators, 10% are lions. How many lions are in the zoo? Well, 80 times 25% will give us the number of predators. So once we know the number of predators, 10% of those predators are lions. So however many the number of predators were, we'll multiply by 10% to get our answer. The last one, a developer is going to make a model of a new skyscraper using a scale of 2 feet equals 75 feet. The building is 1,980 feet tall. How tall will the model be? So this is a little bit trickier because the ticket is feet and feet. Really, though, when we're thinking about this, we're talking about the size of the model and the size of the actual skyscraper. And we know that the model is going to be a heck of a lot smaller than the actual size skyscraper. So if the model is 2 feet, the actual skyscraper is 75 feet. And we know, because the problem tells us, that the real building is 1,980 feet. So that's going to go where we're keeping track of the size of the actual building. What we don't know is how tall will the model be. There's our unknown, n, x, a, whatever variable you want to use. Again, you're going to cross multiply here, so you'll get 75 times n, which is 75n, equals, you'll cross multiply here, 2 times 1,980, you'll get that answer. You'll divide each side by 75, and it's going to tell us exactly how tall the model is. Okay, today is the last day of review with scale factors, and the question is the same as how can scale factors be used to solve problems. So here's an error analysis. A playground is shown below. If the playground is enlarged by a scale factor of 1.5, what is the area of the playground? So this is a student's work. It's wrong. You have 2 jobs. First, solve this problem correctly. Second, see if you can figure out where the student went wrong. Take 3 or 4 minutes and answer the question. Okay, so just looking at this, it looks to me what the student did is they found the area of this rectangle. They knew the formula was length times width. They did 18 times 12 and got 216, and then they did 216 and multiplied that by 1.5. But that's not right, because when you enlarge this by a scale factor of 1.5, what that means is the length is multiplied by 1.5. So if you pick your calculator up and do 18 times 1.5, it gives you 27. The width is also multiplied by 1.5, so if you pick your calculator up and do 12 times 1.5, it gives you 18. So to find the area of this rectangle, length times width, is actually 27 times 18, which is 486 square feet, which is a lot different than what this student got with 324 square feet. The key here is anytime you're dealing with scale factor, whether it's enlarged like 1.5 or if it's shrunk like 1/4 or 0.5, you're always multiplying that scale factor. Okay, couple examples here. The first one, a regular sandbox has a length of 8 feet and a width of 6 feet. So if the sandbox is going to be shrunk with a scale factor of 0.75, what will the dimensions of the sandbox be? So a couple key things here. First of all, I know the size of the original. It's 8 by 6. I know it's going to be shrunk with a scale factor of 0.75. So my new rectangle needs to be having sides that are smaller than 8 and 6. And I need to know what will the dimensions of the new sandbox be. And dimensions means the length and width. So the easiest way to do this to start off is to draw a picture. Here's what we started at. We started with an 8 by 6. When I take 8 and multiply it by my scale factor of 0.75, 8 times 0.75 gives me 6. When I take my width which is 6, and multiply it by 0.75. It gives me 4.5. So my new dimensions of this, it started as an 8 foot by 6 foot, and it became a 6 by 4.5. So my new dimensions will be 6 feet by 4.5 feet. That is my length and width of my new rectangle. So taking this a step further, if I need to find the area of my new sandbox, well, I know it's rectangular, and I know area is length times width, so all I'll have to do to figure that out is go ahead and do 6 times 4.5. So take your calculator out, determine what the area is, and mark this down somewhere because we're going to use it in a little bit. To continue to follow up here, if I need the perimeter of the new sandbox, well, I know that perimeter is the distance around an object. It's all 4 sides. So a common mistake for perimeter would be to say 10.5 and just add those sides up. But no, we need all 4 sides. So that's also 4.5 or 4.5, and that is also 6. So when I add up all my sides, 6 plus 6 is 12. 4.5 plus 4.5 is 9. So my perimeter is going to be 21 feet. So my perimeter is 21 feet. My area is, from the previous problem, 6 times 4.5, which if you did not figure it out, the area of this is 27. So I have an area of 27 and a perimeter of 21. It's important to know this because it's going to help us with our next 2 problems here, just taking it one step further. If the school wants to cover the bottom of the sandbox with plywood that costs $1.25 per square foot, how much will they spend? Well, if they're going to cover it up, that means they're going to put the plywood all on the inside, and the inside represents area. If I know the area is 27 square feet and I'm spending $1.25 per square foot to get my answer, I'm going to have to do $1.25 times 27, and I'm going to get $33.75. Take your time with this and copy this into your notebook. Finally, if the school is going to put a fence around the sandbox, I know that's perimeter, and fencing costs $2.50. If the perimeter is 21 feet, and every one of those feet is costing me $2.50, I have to do 21, which is the number of feet, times $2.50, which gives me $52.50 to put that fencing up. If you need to go back and put anything in your notes, pause it now and do so. Okay, try these 2 on your own. It should take you around 6 minutes to get these done. Pause the tape until you're finished. Okay, the first one. Your work should look something like this. Here is the original rectangle. It has a length of 20 and a width of 10. The rectangle is shrunk using a scale factor of 1/4, so I know my sides have to get smaller. 20 times 1/4 is 5. 10 times 1/4 is 2.5. You always multiply the scale factors. Ultimately, the question wants to know, what is the area of the rectangle after it's shrunk? Well, it's a rectangle. Area is length times width. Our new dimensions is 5 by 2.5. 5 times 2.5 is 12.5 square feet. The second one, this is not any harder, it's just one additional step. It gives us a drawing here, and the flower bed is enlarged with a scale factor of 3. If you go to the previous slide, you see that this square has 4 identical hash marks, meaning all those sides are congruent, meaning it's got to be a square. So, if it's enlarged with a scale factor of 3, that means each side will measure 27 because it's a square. 27 times 27 is 729 square feet. If we are spreading dirt on the bottom, that means we are going to cover this entire flower bed with dirt. And it's 729 square feet of garden, and dirt costs $1.25 per square foot. 729 times $1.25 is $911.25 to cover the entire thing with dirt. Okay, your work for today. It's a mixed review. It's 15 questions. You are going to take the assessment on this on Monday. If you need help, make sure you see your teacher.